If it's a solar eclipse, the Earth is in the shadow of the moon. If it's a lunar eclipse, the moon is in the shadow of the Earth. So here's the sun on the left, the moon is in between the Earth, and this area that is darkened right here, that's the shadow of the moon. And if the moon is positioned just right, there is a band of darkness on the Earth, and that's what we call the eclipse. Now, there are two parts to the shadow. This black area is called the umbra. Think about the word umbrella, okay? Keeps us, it's dark. And then this is called the penumbra, which is a partial shadow. In other words, part of the sunlight is able to come over here and give us light, and likewise the other side of the sun over here will give us some light. So those areas are where we have a partial eclipse. And that's going to be the case in Boone. We're going to be in that penumbra, and we will only have a partial eclipse. There's the sun, the Earth, the moon, and Venus. And so if I move it, you can see what's happening. The moon goes around the Earth like this, okay? And so does Venus. Venus, of course, going around the sun independently. We're not worried about it. So let's say we have right here, when the Earth has a solar eclipse, and you'll notice that one side of the moon is white. It's in the sunlight. The other side is dark. So that's this side over here, right there, that is facing the Earth at this point. And we don't see it. And so that's why it's strange. All of a sudden there's the sun, and then something tends to start covering it up. So let's take a look and see what happens if the moon goes halfway around. The lunar eclipse occurs because the Earth is between the sun and the moon. And over here we have a lunar eclipse. And you'll notice it looks red. Why does a lunar eclipse look red? It looks red because around the Earth is an atmosphere. And the first light that we see in the morning is red, okay? And consequently, that is bent. And there's refraction going on. And as a result, then, refraction causes this space in between to be red. And we see that lunar eclipse as being red. So over here now, you'll notice the side facing the Earth is the bright side. Okay? That bright side means we see a full moon. But when the Earth gets in the way, because now it's in that way, it's in the way of the sunlight, we see a lunar eclipse. So that's the difference between a lunar eclipse. It's just the position of the moon relative to the sun and the Earth. So on August the 7th, we had a lunar eclipse. Not in this part of the world, it was in a different part of the world. But now if we wait 14 more days right here, then come on the 21st, we'll have a solar eclipse, because now the moon is between the Earth and the sun. Now let's think of this. This white-looking object is the moon. And now as we're above the moon, and over here you see the shadow, and as the shadow hits the Earth, you see, there is that totality occurring. Now you'll notice the darker blue here, that's where the penumbra is, and this is where the partial eclipse is going to occur. And you'll notice it covers all of North America, it covers Greenland, Iceland, and eventually you'll see it come around. There's a little bit of the British Isles, and a little bit of Western Europe is going to be able to see this. And this occurrence is going to take 90 minutes to go from Oregon all the way across to South Carolina. 90 minutes to travel across the continent. And so this is the first eclipse since 1918 that crossed the continent in a more or less east to west direction. Okay. So what about Boone? The party starts at 1:09. The center of the eclipse, that is where there's a maximum eclipse, is at 1838, or that would be 2:38. in the afternoon. So if you look at north, say close to where Howard's Knob is now from here, if we go 90 degrees, we're looking east. If we go 180, we're looking south. If we go 270, we're looking west, you see. So this tells us about where it is. So it's going to be almost south. South would be 180. Then at the maximum of the eclipse, it'll be beyond south, a little bit towards the west at 216 degrees. And at the altitude will be 61. And then finally when it's over, 48 degrees will be the altitude and 244. So not quite west, but almost. So why do I give this? Why is this information good? It's because you want to keep yourself away from trees. Okay? Short trees are okay, but tall trees may be a problem. So that gives you a guide for that. Now, how long is it between 109 and 401? Beginning and end, that's 2 hours and 51 minutes and a few seconds there. And we're going to see 96.4% of the light from the sun will be covered. Okay, it'll be very, very thin, like just a very small crescent. If you look at the area, that's called the obscuration, 96.2%. When did Boone have totality? The last time was August the 7th, 1869. And so it came up from Alaska and through British Columbia and then I think that's Alberta. Yeah, Alberta, and then on down through Montana and the Dakotas, Iowa, Illinois, Indiana, Kentucky, a little bit of southwestern Virginia, and into North Carolina. But that's a strange eclipse because look how white it is. It's covering almost the entire state with that eclipse, you see. And so there's another eclipse that's occurring in 1900, May the 28th, that covers up part of that wasn't. So in a sense, this eclipse that we're going to be having in 2017, next week, will be the part that will actually cover the part that wasn't covered before. So, and if you look into the future, in 2099, there's another one that will go in that area where Manteo is sticking out right here, this little part right in here, it will cover that. Eye protection. You must have something over your eyes if you're looking at the sun. Use special eclipse glasses or proper solar filters. And those must cover your eyes when you're looking at the sun because it can damage the retina. Now yes.
So would that be from 109 until the very end?
Yes, right, for 3 hours, almost. That's right. Your retina will be damaged and partial or total blindness could occur. Mm-hmm. Now, unfortunately, some of it is irreversible. Sometimes you can reverse some of it, but you don't see it at the time. There's a chemical reaction that occurs in the retina, and so you go to bed and you can see. The next morning you wake up and you can't see. So it's insidious in that regard. So never wear anything like sunglasses or variable tint glasses, that darken in the sunlight. Those will not work. Those will